In this video, I'm going to discuss using synthetic division as an alternative to using long division for dividing polynomials. Okay, so our first example, we have this polynomial, it's degree 4, and we can divide it. Let's say we're going to divide this big thing by something like x minus 3. Okay, so how does this work? Well, synthetic division works as long as we're dividing by a binomial, so two terms, and it has to be linear, so the degree is 1. And it works as long as you're dividing by x minus k. So your k right here is just some constant that you have in here. So the way this works, x minus k is going to be our divisor, like x minus 3. So the k, in our case 3, is going to go on the outside. I'm going to draw a big bar right here, kind of like a division bar, but upside down. And we're going to focus only on the coefficients of our terms. So 2 times x to the 4th, and then our x cubed term is negative 1, our x squared term is negative 17, our x term is 1, and our constant is 15. Okay, so we have this set up. This is what it's going to look like. We have this k value out here that comes from our x minus k as our divisor. And then we have all of our coefficients of our dividend polynomial that we're going to use. So 2, negative 1, negative 17, 1, and 15. So here's how the algorithm is going to work. You're going to bring down the first number, whatever it is, so put a 2 right there. And then we're going to go through a series of multiplications and additions. So we're going to take this 3 times the 2 to make 6, and then we're going to add these two numbers. So negative 1 plus 6 is 5. Then it's a multiplication of 3 times 5, it's 15, and then our addition, negative 17 plus 15 is negative 2. Then our multiplication, 3 times negative 2 is negative 6. Our addition, 1 plus a negative 6 is a negative 5. And then 3 times negative 5 is negative 15. And we add these last ones, we get 0. Sometimes I put a little bar right here. This guy right here is going to be our remainder. Since our remainder was 0, we know that x minus 3 is a factor of this polynomial. Well, okay, so what's this mean for our quotient then? We've just got numbers here. So this is a 4th degree polynomial, and this is a linear, so 1st degree polynomial. So when we divide, 4 minus 1 makes 3, so our leading term, or the degree of this polynomial, will be 3. And this will be my x squared term, my x term, and I put c for constant. So how does this work? Well, 2x cubed, this is positive, so plus 5 x squared, negative, so minus 2x, negative, so minus 5. So here, right here is my quotient when I take this 4th degree polynomial and divide it by x minus 3. In the first example that we did, it came out really nice. So our x minus 3 was actually a factor of my original polynomial. Well, let's see if it doesn't come out nice, and if we have a remainder, kind of what that looks like. So my divisor here needs to be in the form x minus k. Right now I have x plus 2, so that's really kind of like x minus a negative 2. So because the negative and a negative make a positive here. So now my k value equals negative 2. So a good thing here, a good reminder, or a good little thing you can use is just change the sign right here. So if it's a minus, just take your k. If it's plus, take a minus k. So a negative 2 in our case. Okay, so let's set this up. If my value of k is negative 2, that guy is going to go outside. And then I'm going to draw my nice little division bar here. So we're concerned with grabbing the coefficients. So in our case, we're going to use the same polynomial as in the first example. So I'll take 2, negative 1, negative 17, 1, and 15. So here's the way this is going to look. So I bring down my first term to make 2, and then I do that series of multiplications and additions. So negative 2 times 2 is negative 4. Negative 1 and negative 4 makes negative 5. So negative 2 and negative 5 makes positive 10. Negative 17 and 10 makes negative 7. Negative 2 times negative 7 is 14. 1 plus 14 is 15. And negative 2 times 15 is negative 30. So when I add these, 15 and negative 30 is going to be a negative 15, and this is going to be my remainder. Okay, so the last time we had degree 4 divided by degree 1, so 4 minus 1 will cause this to be a cubic term right there. So I'll put the rest of my terms, and that guys are constant. So it'll be 2x cubed minus 5x squared minus 7x plus 15. Well, how do we deal with this? Well, since he's negative, I'm going to put a minus. If he was positive, I put a plus. And it'll be 15 over, and then over my divisor here, so x plus 2. So now here's the answer for this polynomial division problem. In this final example, I'm going to use a polynomial that appears to be missing some terms. I have my degree 5 here, and to the third, and to my linear term here. Well, it looks like I'm missing my to the fourth term and my squared term. So how will that affect my synthetic division? Well, I'm going to come over here. X minus k is what it needs to look like. So it looks like my k is going to be 1. So I'll put my 1 out here. Okay, so x to the fifth is my highest, so its coefficient is 3. X to the fourth is the next term, but it's absent, meaning its coefficient is 0. So I'm going to go ahead and put that placeholder in there with a 0, because we can't miss any degrees here. So 5, 4, 3 is a negative 8. My squared term is also absent, so I'm going to put a 0 for him. My linear term is a 4. My constant is negative 11. Okay, then I'm going to continue as normal. So down with the 3. 1 times 3 is 3. And my addition, 0 plus 3 is 3. 1 times 3 is 3. Negative 8 plus 3 is negative 5. 1 times negative 5 is negative 5. 0 plus negative 5 is negative 5. So 1 times negative 5 is negative 5. 4 plus negative 5 is negative 1. A little bar here for my remainder that goes there. 1 times negative 1 is negative 1. And those two together make a negative 12. Okay, well, I had my degree 5 previously in degree 1, so 5 minus 1 is x to the fourth. So I'm just going to write all these in so you can see the terms, how they're going to lay out. So it'll be 3 x to the fourth plus 3 x cubed minus 5 x squared minus 5x minus 1. And we're not done because we have our remainder. He's negative, so I'm going to put a minus. And again, if he was positive, I'd put a plus. But he's negative, so minus 12 over, and then my divisor, x minus 1. So here's going to be the quotient, the answer to my division problem, when I divide this fifth degree polynomial by x minus 1.